So question number 23, it says there's a set of n elements and a non-empty subset is chosen at random from the set, and all the non-empty subsets are equally likely to be selected. X is the number of elements in a chosen subset, and we need to find out expectation of X, and we have provided 4 expressions for the same. So here, I have first written down the given information that the total number of non-empty subsets is 2 to the power n minus 1, and the number of sets having k elements is nck, because the k elements can be chosen in nck ways. Now, probability of choosing a set having k elements is nck by 2 to the power n minus 1, since all of the sets are equally likely to be chosen, and there are nck sets which have k elements. Let x be the number of elements in a chosen subset. So x is essentially a random variable whose expectation is given by summation k from 0 to n, k into probability x equal to k. Obviously, x is a discrete random variable taking values 0, 1, 2 up to n. So I've simply substituted probability x equal to k here, and after some simplification, we obtain it as n by 2 to the power n minus 1 comes outside, and the sum runs from k from 1 to n minus 1 factorial by k minus 1 factorial into n minus k factorial. And after changing the order, or changing by putting k minus 1 equal to some k prime, we can obtain this to be n by 2 to the power n minus 1 into 2 to the power n minus 1, which simplifies to this expression, and which you can observe from here is identical to the option C. So question number 24 says that Z is the standard normal random variable. So we have to check 4 statements which are true for whether they're true or not for any x greater than 0. So yeah, so Z follows normal 0, 1, and the first option asks us about probability Z greater than x. So probability Z greater than x can be written down as 1 minus probability Z less than equal to x, which is 1 minus cap phi of x, which is cap phi of minus x. And obviously, cap phi of minus x is defined as probability Z less than minus x. So A is correct. Now let us check option number 2. Probability mod Z greater than x is equal to probability Z greater than x plus probability Z less than minus x, which comes out to be twice of probability Z greater than x. You can definitely think of how this comes, and you can obviously use the symmetric property of the standard normal random variable, or simply use the result already obtained in verifying option A. You simply substitute probability Z less than minus x as probability Z greater than x. So B is correct as well. Moving to option 3, which says probability mod Z less than x, that is equal to 1 minus probability mod Z greater than x, which is 1 minus twice of probability Z greater than x, which you can observe from option B. So option C is true as well. And we can again, from this step, we can again simplify probability Z greater than x as 1 minus probability Z less than x, and it turns out to be this. So, which is identical to option D. So we can observe that A, B, C, D, all the 4 options are correct for this question.
Hello guys, welcome to Cheenta School of Statistics and Data Science. We are a team of extremely passionate teachers, researchers and statisticians from the top universities of India and USA. Our mission is to help you curve your career in statistics, data science and machine learning. How do we do that? Number 1, we help you build your foundations. We achieve that by making an optimized plan for your learning journey. Number 2, we help you prepare and ace your entrance examinations in statistics and data science, like IIT MS, ISI Mstat, and CMI MSc Data Science. Number 3, we give our absolute best to help you design your career by organizing workshops and certified data science courses. To book a trial class for your preparation courses of IIT MS, ISI Mstat, and CMI MSc Data Science, check out the first link in the description below. If you're enjoying the video, show some love by liking the video and subscribing to the channel. We welcome you again to this passionate community of budding statisticians and data scientists. Let's enjoy the rest of the video. Stay tuned and stay blessed.
Question 25 says that xn is a sequence of positive reals, yn is xn by 1 plus xn, and we have to check which of the following are true. Xn is convergent if yn is convergent, yn is convergent if xn is convergent, yn is bounded if xn is bounded, and xn is bounded if yn is bounded. There are 4 options. We need to check also. So, in the first we can observe that since xn is greater than 0 and yn is xn by 1 plus xn, then 0 less than yn less than equal to 1 for all n belongs to natural numbers. So, yn is bounded irrespective of what xn is. Now, checking options, we first go for option B, that is we check that limit n tends to infinity xn is some c. So we assume that, and then we can observe that limit n tending to infinity yn is c by 1 plus c for all c belongs to R, and thus B is true. However, xn is yn by 1 minus yn. So if limit n tending to infinity yn is equal to 1, then limit n tending to infinity xn doesn't exist. So since here we can observe that xn is yn by 1 minus yn, so if the denominator goes to 0, then obviously xn won't have a limit, so A is not true. However, B is true. And yn is always bounded irrespective of choice of xn. So we can observe here that C is trivially true, that even if xn is bounded, yn is obviously bounded. However, we can observe a counter example that if xn is equal to n, then yn, which is n by 1 plus n, that is bounded by 0 and 1 again, but xn obviously isn't. Xn is the natural numbers. So B and C are the correct options here. Okay, any questions?